Hello, everybody. Okay, so we're going to finish up our discussion of chapter 4 today. And our last lesson is zeros in the product. And our essential question is how do you know you have the correct number of decimal places in your product? And we're on page 197 of the fifth grade Go Math textbook. So let's look at the unlock the problem. So there's connect part here, right? So when decimals are multiplied, the product may not have enough digits to place the decimal point. In these cases, you may need to write additional zeros as placeholders. Students are racing typical garden snails and measuring the distance the snails travel in 1 minute. Chris's snail travels a distance of 2/10 foot. Jamie's snail travels 4/10 times as far as Chris's snail. How far does Jamie's snail travel? So 2/10 of a foot is important because that's how far one snail travels. And the other one travels 4/10 times as far as the other snail. So it wants to know how far does Jamie's snail travel. So in the given information, we basically have to find 4/10 of 2/10. To figure out or determine the distance Jamie's snail travels. Okay. All right. So here are the steps. So multiply 4/10 times 2/10. We're going to treat this as if they were just whole numbers. 4 times 2. Okay. 4 times 2 is 8, right? Well, we know that this 2 is actually 2/10, and we know that the 4 is actually 8/10. So we're multiplying a tenth times a tenth, right? So tenths times tenths is hundredths. And we know that just from patterns. Okay. So 1/10 times 1/10 we know is equal to 100th. So we have to have a decimal number that is in the hundredths. So we have to make sure we have a 0.08. Okay, so we have two decimal points, positions. So since the tenths are being multiplied by tenths, the product will show hundredths. So this isn't really new from anything that we've already discussed in this chapter. Okay, so step 3, place the decimal point. We did that. We counted tenths times tenths, hundredths. Are there enough digits in the product to place the decimal point? There wasn't. We only had an 8, right? 4 times 2 is 8. So we had to add a 0 to our product. So we write zeros as needed to the left of the whole number product to place the decimal point. So Jamie Snell travels a distance of 8/100ths of a foot. Now, what about when we're multiplying by money? In this case, sometimes we have too many zeros. Because when we talk about money, we want to stop at the hundredths. We don't have a thousandth coin, right? So we have to stop at the hundredths, the pennies. So here we have 2/10 times 30 cents, or 30 hundredths. So we're going to just multiply, as with whole numbers, 30 times 2. Okay, and what are the whole numbers you'll multiply? 30 times 2, which is 60. 2 times 0 is 0, and 2 times 3 is 6. So we have 60. Now we have to decide the position of the decimal point. And we have hundredths times tenths. And we know that hundredths times tenths is thousandths. Well, right now there's not enough decimal points or digits to place the decimal point. So place the decimal point, write zeros to the left of the whole number product as needed. Well, since we have to show thousandths, we have to put one to the left. If we put it to the right, we change the value. Okay. So we want 60 thousandths, which makes sense. Basically, we're taking 2/10 of 30, right? So that would be basically 60 cents divided by 10, which would be 6 cents. All right, since the problem involves dollars and cents, what place value should you use to show the cents? So here, while we had to add a zero to put the place value to make it into the thousands place, we don't write money this way, right? So we're going to drop off the thousands because when we show cents, we only go out to the hundredths place. So 2/10 times 30 cents is just written as 6 cents. All right, let's go on to try this one. So we have 2/10 times 5 hundredths. Well, we're just going to multiply 5 times 2. Okay, treat it as if it was whole numbers, 5 times 2. So we get 10. Okay. And we have hundredths times tenths. So our final product would be in the thousandths. So right now I only have hundredths. So I have to add a zero to the left of the whole number product, 10, and that gives us 10 thousandths. So what did we do? Well, I multiplied, as with whole numbers. All right, so then we had to decide where to put the decimal point. Why did we go to thousands? That's because hundredths times tenths equals thousandths. All right, so again, 10 thousandths. All right, so page 199. All right, write zeros in the product. Think, hundredths are multiplied by tenths. What should be the place value of the product? Okay, well, hundredths times tenths. That's going to equal thousandths, right? Okay, well, right now, if we multiply the whole numbers, we have 35. And if I put the decimal point in front of the 3, we'd say that's 35 hundredths. But we need a number that's in the thousandths. So we're going to place a decimal point, a 0 to the left of the 35, and put in the decimal point to the left of the 0. So 0.035 or 35 thousandths. Number 2, well, 3 times 2 is 6, and a tenth times a tenth equals a hundredth. So let's look at that. 0.01, right, is hundredths. Well, here we only have 6. If I put the decimal point to the left of 6, I'd have 6 tenths, not 6 hundredths. So we have to add the 0 to the left of the 6 and then put the decimal point. Okay, number 3. 2 times 2 is 4, right? Well, we're multiplying hundredths times tenths. Hundredths times tenths equals thousandths. Well, right now we're at 4, right? So we need to add 2 zeros to the left so that we have thousandths. Number 4. 5 times 8. 5 times 8 is 40. We're multiplying 2 hundredths by 1/10. Again, it's 1 thousandths. Right now, I would only have 40 hundredths. So we're going to add a 0 to the left and put the decimal point. Number 5, 9 times 7, 63. Hundredths times tenth equals thousandths. So we're going to add a 0 in front of the 63, then put the decimal point, and we have 63 thousandths. I do want to go back to number 4. I overlooked the dollar sign. Okay, so we don't want to write it as 40 thousandths. Okay, because we're dealing with money, we just want to drop off the thousandths and leave it as 4 cents. Okay, 4 hundredths is equivalent to 40 thousandths. But in money amount, we stop at the pennies or the hundredths place. All right, so make sure you notice dollar amounts in problems. Number 6, well, we basically have 2 times 1. Well, 2 times 1 is 2. And we have a tenth times a tenth. Tenth and tenth. That's going to equal a hundredth. Well, if we put the decimal point right now, we'd have 2 tenths. So we're going to have to add a 0 to the left of the 2 and put a decimal point. All right, number 7. 3 times 3 is 9. I'm multiplying 1/10 times 1/10. So my answer is 100th. Whereas the product is in the hundredths. So let's add the 0 to the left of the 9, and we have 9 hundredths. Number 8, 5 times 3, 15. We'll have hundredths times tenths, which is thousandths. Well, right now, if I put the decimal point, I'd have 15 hundredths. So I'm going to put the 0 there and put the decimal point in front of the 0. So 15 thousandths. 4 times 2 is 8. Hundredths times tenths equals thousandths. So right now we only have 8. That would be 8 tenths. If I put 1 0, that's 8 hundredths. So I need a second 0 to have 8 thousandths. All right, number 10. Number 10 is a money amount problem. And we have 40 times 1. Well, that's just 40, right? And we have hundredths times tenth, which we know is a thousandth. So if we put the 0 on there, so we're in the thousandths. Okay, so we know that it's basically 4 cents because we're dealing with money again. So we're going to drop off the 0, which is in the thousandths place. All right, number 11. 3 hundredths times 6 tenths equals some number. Well, 6 times 3 is 18. I'm multiplying a hundredth times a tenth. So that's a thousandth. So we're going to put a 0 there, the decimal point. So n equals 18 thousandths. Number 12, some number times 2 tenths is 8 hundredths. Well, 2 times what is 8? 4, right? So now we just have to figure out, is it 4 whole number? Is it 4 as a whole number? Is it 4 tenths? Is it 4 hundredths? So here we're multiplying by tenth, right? And my product is in the hundredths. So that means this has to be multiplied by tenths. A tenth times a tenth equals hundredths. So n equals 4 tenths. And number 13, 9 hundredths times something is 63 thousandths. Well, I know that 9 times 7 is 63. So here we're multiplying by hundredths. My product is in the thousandths, which is 3 place values to the right of the decimal point. So right now I have hundredths, so that means this number has to be tenths. So it's 9 hundredths times 7 tenths. All right, 14. Michael multiplies 2 tenths by a number. He records the product as 8 thousandths. What number did Michael use? So this is the same as 11 through 13. So we'd set this problem up by going something like this. 2 tenths times some number equals 8 thousandths. Well, 2 times what is 8? 4. All right, now we have to figure out what is the value of the 4. Is it 4? Is it 4 tenths? Is it 4 hundredths? Is it 4 thousandths? Well, here we're multiplying by a tenth, right? And our product is in the thousandths. So a tenth times what gives us thousandths? 100th. Okay, so 100th times a tenth is thousandths. So n equals 400th. Page 200, number 15. On an average day, a garden snail can travel about 5/100th of a mile. The snail travels 2/10 times as far as the average distance on day 1. It travels 6/10 as far as the average distance on day 2. How far does it travel in 2 days? All right. So if it traveled the average, it would be 5/100ths plus 5/100ths for the 2 days, but it's not. This snail goes further both days. So we know our number is going to be greater than 5/100ths of a mile. So what do we need to find? We need to find the distance the snail traveled in 2 days. What information do we need to use in the problem? Well, we need to know that it's 5/10 mile per day on average. Day 1, two tenths times as far as average. And day 2, 6/10 times as far as the average. Which operations are we going to use to solve this? Well, we have to multiply to figure out how much the snail travels each day. And then we're going to have to add those 2 days to get the total distance. Okay, so let's go ahead and do that. So day 1 is 2/10 times 5/100. And day 2 will be 6/10 times 5/100. Well, 2 times 5 is 10. We're multiplying a 10th by 100th. So our answer is in the thousandths. 100th times 10th is thousandths. So 6 times 5 is 30. 6 times 5 is 30. And again, we're multiplying a 10th by 100th. So my answer has to be in the thousandths. Now let's just add those together. 30 thousandths plus 10 thousandths. We'll wind up with 40 thousandths of a mile in 2 days, or 4/100ths of a mile. So we can say 4/100ths or 40,000th mile. Those they're equivalent. All right, 16. In a science experiment, Tania uses 8/10 ounce of water to create a reaction. She wants the next reaction to be 1/10 times the size of the previous reaction. How much water should she use? Well, so we have 8/10, and she wants it to be 1/10 as big the second time. Well, 8 times 1 is 8. A 10th times a 10th is hundredths. So 0.08. And 17. The library is 5/10 mile from Celine's house. The dog park is 3/10 times as far as Celine's house is as the library. How far is the dog park from Celine's house? Write an equation and solve. Okay, so what are we doing? We're doing 5/10. That's the distance from her house to the library. And we want to go from the dog park, which is 3/10 times as far as the library. So times 3/10 equals n, the number of miles. So 5 times 3 is 15. We're multiplying a 10th times a 10th. So our answer is in the hundredths. So 1/1500th of a mile. To the dog park from Celine's house. Okay, so that's it for chapter 4. So in chapter 5, we're going to work with dividing decimals. So until then, I will see you soon.